Welcome to ADF Insider about using JavaScript in Oracle ADF and Oracle ADF Faces application development. My name is Frank Nymphius and I'm from the Oracle JDeveloper and ADF product management team. JavaScript as a language is not new, and many developers have an experience with this scripting language from previous assignments in web application development, where they use JavaScript to build in animation or data validation or data manipulation on the browser client. Until Ajax, JavaScript clearly has been underrated, and many companies did abandon JavaScript just because of the security risk it imposes. The change came with the XML/HTTP request object that allows JavaScript to call out to the server to fetch data asynchronously and display to the user when the data was streamed down to the client. This allowed developers to build more interactive, more dynamic web applications that refresh the screen not when the user navigates off the current page or refreshes the page, but when the data was demanding it. JavaScript, though it has the name Java in it, clearly is not Java, and is not even related to Java. It's an untyped language, which means that an argument you pass to a function may be of a wrong type. It's not checked by the language or by any kind of compiler at runtime. You can do object-oriented programming with JavaScript, though in fact JavaScript is not an object-oriented language. However, some naming conventions and some development principle will allow you to create an object hierarchy with JavaScript that then you can use within especially frameworks to build web applications and client-side interactive programs. Before we go into how to code JavaScript within an ADF Faces environment and how to use that in the context with Oracle ADF, let's have a look at the client-side architecture that the Oracle ADF Faces component set provides. The ADF Faces component architecture is a hybrid approach when it comes to rendering. As a Java Server Faces component set, rendering is handled by rendering classes, or render kits, so to say. When we render a UI component on the browser client, then we try to render as much as we can using HTML to ensure good performance and to not generate unnecessary objects that are then handled and downloaded to the client. So only components that have functionality which requires behavior, like the table where you can swap out the table index, where you can change column sorting and ordering, or like a spinner control where you can move a control to change the value of the component. Only this kind of component by default need to have a JavaScript object to be present on the client. Input text fields or output text field don't have a behavior, and for that reason don't necessarily need to have an object on the client, for as long as the developer you don't want to code against this. Every component that you want to code against using JavaScript requires to have a JavaScript object presentation on the client side. When we develop with JavaScript in the context of ADF Faces, then there are two types of JavaScript objects that are present on the client side. One is a public component object. This is a public API that exposes every component that exists as a Java Server Faces component in ADF Faces as a JavaScript object. And then there is an internal peer object. As we all know, JavaScript is handled differently within browsers and browser versions and browser types. So to translate an API call appropriately for the browser being used, there's a specific kind of proxy class required, which in the case of ADF Faces is called the internal peer class and the peer object class. So the peer class translates the request coming through JavaScript to the public API to the underlying browser. As a developer, you don't work with the internal peer object. The internal peer object is an internal detail that you build if you're a component developer. If you're an application developer, then there's nothing to do with the internal peer object, you just work with the public APIs. This is a graphical overview of the architecture that we have in ADF Faces. On the right hand side you see the Java Server Faces foundation. There is the Java Server Faces component tree that we keep in memory on the server side, and that represents the hierarchical structure of a page as it is displayed in the browser. The renderer component makes sure that there's a display in the browser, and as you know, the renderer might be for different devices like PDA or mobile, but if it's for the browser, then the rich render kit is used, and this brings down to the client a mixture of generated HTML and JavaScript objects, as I mentioned before. It's important to notice here that the UI components that we have in ADF Faces on the client side are not the DOM objects that you see with introspection tools. Instead, every UI component in Java Server Faces that we find in the ADF Faces library has a JavaScript object representation that also goes along with the naming convention that we use on the server side. So on the server side, an input text field is based on a rich input text object. On the same side, on the client side, we do have an ADF rich input text object. If you look to the DOM, then what you see is an hierarchy of generated markup, and the DOM is good for that. It allows you to access HTML markup, which is a structured view of components that are on a page. But this is not the same as a UI component. A UI component which has a property like set visible, get visible, set auto submit, get auto submit, set value, get value, set immediate, get immediate. This kind of property access that you have on the ADF Faces component set, this is not available in the DOM. This is only available on the UI component. And for this reason, you never code against the DOM when you work with ADF Faces rich client. If you develop JavaScript against ADF Faces, you always enter into the client architecture through the ADF page, which is the top level object describing the document of the ADF Faces page. When you go to OTN or oracle.com and you access the documentation library, then under the API libraries there is a JavaScript API reference that you can use to look up components and have some read into the architecture and what different components and event objects are doing and what they allow you to do. In this case, we have an ADF rich input text component up here in the screenshot, and what you can clearly see is, first of all, the inheritance structure. ADF rich input text field is inherited from ADF UI input, ADF UI editable value, and ADF UI value. What this means for an application developer is that from all of these objects that we inherit the functionality from, we get properties and maybe events that we can then work with on the JavaScript side. On the method summary, you see all the properties that I have available on the server for the input text field I also have available in JavaScript. So I can set the columns that a text field will use to identify the number of characters that fit into a field. I can read the number of columns. I could set it to disabled and get the disabled properties. I can set inline style sheet. I can get inline style sheet, and so on. I can set the label, get the label, value, read only, and so on. So this all can be accessed through properties, in that I get a handle to the ADF rich input text instance, and then I just call a getter or a setter on it, because the client-side architecture is an exact mirror of the server-side architecture. As I mentioned, JavaScript is not a typed language, and it doesn't know about types, argument types, but it also doesn't know about scopes. In object-oriented programming, however, you need to have a scope to protect software implementation or keep implementations private so that it's not changed throughout the application development process. And for this, the scopes of public, private, protected, and packaged is introduced in ADF Faces rich client. And the reason we have this slide up here is because if you use a DOM introspection tool like Firebug, then this is exactly what it will display. It wouldn't show you public, private and protected, but it will show you different naming conventions that are used when defining functions. So all public functions, which are good for you to use in your application developments, show as a camel case function name, naming convention, starting with a lowercase character. So things like find component or find component by absolute ID, these are public APIs that is good to use in custom application development. Then there are private functions. Private functions all start with a leading underline in the naming. So the convention is everything that has a leading underline in the naming is private. Now that could be a private function or private attribute. Now this is not to use for anyone except for the developer who is building this in the context of the component that he's building. A third scope is protected, and protected names are pretty similar to public function names except for that they start with a uppercase character. Protected functions are only good to use for component developers. They are not good to use for application developers. Application developers only use public functions. Then there is a package structure and hierarchy in ADF Faces that helps you to identify objects that are not meant to be used. Every package structure that has the name internal in it is meant to be internal. Now that means typically it contains peer objects which you are not supposed to work with. As an application developer, you should really stay away from modifying internal peer classes or overriding internal peer classes, because that definitely is a recipe to bring you into trouble in the future, because changes within private, protected and packaged objects are without further notice. So now that we are all set, that we know that there's a client architecture, that there's a JavaScript API that you can use, that there's a documentation you can use, what do we use JavaScript for? Well, we use JavaScript for everything we cannot find natively in ADF Faces. So if there is functionality in ADF Faces that you cannot get through Java Server Faces or Java, then JavaScript is an option. Don't turn it the other way around. Don't code in JavaScript only because you don't know how to do it in Java Server Faces. The use of JavaScript is not an excuse for not having to learn Java Server Faces or the ADF Faces APIs. So the solution should always be found first using Java Server Faces, and if you can't find it there, use JavaScript for that. And there are many reasons why you go with that, and we cover that later. So let's have a look at the first example. In this example, JavaScript is used to ensure users provide the correct data in the filter fields of a table. As you know, you can configure a table when you create it to have this filter field above the column so that you can query the table in addition to what the underlying query is coming from the business service. In the employees field, for instance, if I type an employee number that I want to search for and I put in 123, that works fine. But if I want to try ABC, you see it's suppressed, it's not entered into the field. Now this makes sure that the users cannot provide wrong entries that I would have to handle in my code. The same for the first name. If I try 123, it doesn't work. If I do ABC, it works here. And this is a little example of how you can use JavaScript, because JavaScript in this case is actively listening for the user input into this filter field, and then if the input is not of the correct character range, it will just suppress the input. Another example where you want to use JavaScript is to handle long-running queries. So, simulating a long-running query, if I press enter to run the query, a glass pane is opened up put in front of the screen, and then there's a splash screen showing, identifying to the user that there's some progress in the back happening. The glass pane is needed in a lot of applications to avoid users to continue clicking in the application or trying to cancel the event. Long-running queries not only are queries against the database that might take some time to bring up all the data, that also might be an access to the web service. Now what you want to do is you want to have a trigger on the client side knowing when the screen is blocked or busy and when this is released, so when the screen is ready for additional user input. And this can be done with JavaScript, because on the JavaScript side we have access to the screen state, so we can listen for when the screen is busy. And busy can mean just a simple query where maybe the time would be too short just to bring up a splash screen, but busy also means that if it's a long-running query, like in this case where we added a thread in the background to take at least 6 seconds to run, that we can bring up a pop-up with a custom information for the user that there's something going on and that there is no worry that this application will return as soon as the data is fetched. So this is one example where you can use JavaScript, which you cannot do easily within native Java Surface or ADF Faces means. So let's get started on how you build this. So we've seen how JavaScript works, and I already mentioned what it's good for and what you shouldn't use it for. It's not a replacement for learning Java Surfaces. It's not a silver bullet to use. It's something that you want to use if you need a feature on the client side that you cannot code within Java Surface or ADF Faces. But let's see how you get started, how you get productive when using JavaScript in ADF Faces. First of all, your JavaScript needs to be added to the page. The tag to use for that is AF resource. If you're a long-time follower of JDeveloper 11g, then you might have seen different ways of adding JavaScript to a page, be it the TRH script tag coming from Trinidad, the meta container that you can add to the AF document tag, and so on. Now, this all now is replaced with this AF resource tag. The AF resource tag makes sure that the JavaScript or style sheet that you want to add to a page gets added to the HTML header and downloaded with high performance through the header and not as part of the body. The AF resource tag is a child of AF document, and you can basically put it wherever you want. So it's not really necessary to have this being the first tag within your page. It can be wherever you want to put it. As a personal preferences, I put the AF resource tag next to where I'm using the code, so that if someone is reviewing the code I'm writing, then there's no need to step out of the page scope in reading the page sources just to find the JavaScript. However, in productive environment, my preference would change, and here I would prefer to use reusable libraries, so I don't have to write the code over and over again. I would write generic code. And again, for this, AF resource can be used. In this case, it would reference an external library file, as you can see here with a custom JS code.js. These generic JavaScript files have the advantage that the browser can cache the files, which means you don't have to bring it down to the client with every page request, which also reduces the size of a page. The second way to use the AF resource is to put the JavaScript into the body of the AF resource tag. Now this is what I as a product manager tend to use for my demos, because as I mentioned, my preference is that if users read my demo that I'm writing, that they understand what exactly the JavaScript is doing without stepping out to different JavaScript file. But in production, the first option definitely is preferable. Anyway, the AF resource tag cannot have both in once. So you have to do the decision either to use the AF resource tag with an external file reference or use it to put JavaScript in its body. You can have more than one AF resource tag on a document. So you can have as many as you want. So you can have a mixture of AF resource tags, reference and external files, and other resource tags that have the JavaScript in the body, which typically you want to do if you have a mixture of generic reusable code and page-specific code. So once you start developing with JavaScript in the ADF Faces client architecture, you need to get a hold of a component to read or set values on. So one entry to this would be the ADF page dot, and now all uppercase, page object. Now this is our document root. From here you can access to all of the components that have a JavaScript object representation. And you do this by find component by absolute ID, where the absolute ID is the component ID prefixed with possible naming containers. Naming containers like panel collection always put the ID as a prefix in front of the component ID. So that would be naming container ID colon component ID. Then there is a method called find component by absolute locator. This is the function that you use to find a component that is within a stemmed component, like a table. So if you want to find the output text component, which is in the 6th row of a table, then you use find component by absolute locator. As a general best practice is to avoid hard coding any ID and find a way to use expression language or Java access to dynamically discover the ID, the client ID of a component, and then bring this to the browser client. And one way of doing this would be to use a client attribute, which I will introduce on another slide during this session. So that is the absolute search. A relative search is if you start searching from an existing handle to a component. Say that there is an input text field and the input text field raises a value change event. Then as part of this event object, you get access to the input text component raising that event. And this now allows you, for instance, to look up for peer objects, objects that are next to each other. For this you can use a relative search, find component. So if the source component and the one you want to look up are in the same naming containers, then find component doesn't require you to add the naming container ID as a prefix. However, you always need to be aware of naming containers, and this is why I said the recommendation is to try and generate the client ID. Don't hardcode any ID, don't make any assumption about how the page could look like, because applications typically are always under development. If you build an application today and that is supposed to last for the next 5 or 10 years, then chances are that other co-workers of you work on the same page. Now if they add a naming container around a component that you access in JavaScript, and if they're not aware of that, they're actually breaking your functionality. For this reason, generating the client ID is always a safe bet. One pitfall which a lot of developers trap into is that they try to access an object that doesn't exist. As I mentioned very early, we always try to do a hybrid approach. We try to generate HTML for as much as we can for better performance. Now this means that components like input text fields or output text fields are not represented by their JavaScript object, which is the AF rich input text field for the input text field. To enforce a client to exist, you either set a client listener, and we'll talk about client listeners in a second, or you set the component's client component property to true. Now this property is only available in ADF Faces because that is part of the ADF Faces client architecture. So one of the two must be true for the object on the client side to exist. If none of this is set, then the client object doesn't exist, most likely. So you want to make sure that the object really exists. Now why don't you want to set client component property on any component just in case you need this? Well, the answer is performance. You don't want to undo what we did in our hybrid architecture just for having JavaScript objects on the browser and slow down the whole page rendering. So that's kind of a secret of performance that we have within ADF Faces. So don't set blindly client component properties to true. just do it as sensible as possible. As a JavaScript developer, and for sure you've doing some JavaScript in the past, I'm not sure there are many that haven't done JavaScript in the past. You know that there are events coming from the DOM tree or that you can listen to. Typical events are mouse click, mouse down, mouse up, key press, key up, key down, blur, focus, and many more. Now these are DOM events. These are events that are raised on the page and then bubbling up in the browser to notify all interested parties. In ADF Faces, in addition to DOM events, we also provide component events. And I mentioned already an input text field could have a value change event. So when the value changes, then it raises the event. A table has a query event. An AF query component has a query event. A dialog has a launch event. A dialog has a return event. A table might have a context menu event. So all events that you have on the server side in Java Server Faces for ADF Faces are also present on the client side in JavaScript. And events start with the ADF prefix for the component and then end with the name event. And what we did is in ADF Faces is we also wrapped DOM events into ADF component events. So even events like click, mouse up, mouse down, key up, key down, focus, and so on are wrapped in ADF Faces component events. So there's no need at no time to hook up to the DOM events. And if you look at our component properties, you don't find any DOM specific event handling property like on blur, on focus, and so on. We did have that in 10.1.3, we no longer have that in 11G. In 11G you use a client listener to listen for component events, and the component events are issued on the ADF Faces component. Yeah? So if you have a background in JavaScript development, free yourself from all the skills that you assembled in the past. Forget about the DOM. It's still there, but you're not supposed to use it. Just work with the architecture and you're on a safe ground. So information that we provide within the event is not only about the event, it's about the component on which the event is evoked. We also get an information about the queue state. We also have the chance to cancel the event. We have a chance to stop the event from bubbling up to other interested parties. And that's all what makes sense in the context of a rich framework when you want to code with JavaScript against it. Because always keep in mind the difference between using JavaScript in the context of Java Server Faces and ADF Faces and using JavaScript in some traditional web applications is that the life cycle in Java Server Faces is much more complicated than the life cycle in a traditional web application. To stay within the life cycle, to make sure that there's always a reasonable synchronization between the server side of a Java Server Faces component and the client side with ADF Faces, you use only ADF Faces APIs for your JavaScript programming. Don't step left or right outside it, because that would just risk to break synchronization. Of course, you can use the DOM to look up element by ID, then set the value for an input text field. And in most cases, you're lucky that the value you enter gets to the server side and updates it. But you're kind of bypassing the whole client-side lifecycle that the ADF Faces team builds in to avoid errors being caught on the server that could have been handled on the client side. So I mentioned that the client listener is something you use and that you actually add to listen to a specific event. The client listener is a tag that you find in the ADF Faces component palette under operations. You use this to drag and drop onto the component that you're interested in listening for a specific event. Here on the screenshot you see that the input text field has 2 client listeners assigned, and you can have as many as you want. Just one client listener for each of the events you're interested in. In this example, we're interested in the context menu, so we want to know when the user uses the right mouse on the text field, click on it, and then we want to open a pop-up showing some additional functionality that they could choose from. In the property inspector there are 2 properties for the client listener, method and type. The method is just the name of the JavaScript function you want to call. And shown in the screen we have an AF resource tag, and in the body we have a function defined open pop-up, and this pop-up takes a single argument, which I call EVT for event. I tried not to use event because that is used with so many traditional JavaScript programs just to intercept the native browser event. So I try to find something different. You might go with argument 1 or with arg1, whatever is your choice. The argument is the event object, and it must be within the signature of the function you call. However, it's only the function name that you reference as a method. In this case, the type is context menu, so that means we are listening for the component event, which is context menu, the right mouse key. And then we can respond to this in the function. As I'm adding a client listener to the input text field, the input text field automatically will have a JavaScript object representation in the ADF Faces client. So let's look at an example that uses the client listener to do something that's natively is not provided within Oracle ADF Faces. A frequent customer requirement with ADF Faces is to perform an operation on a table in response to a double click. A double click is nothing that we have a listener for on the Java Server Faces component itself. So what I can do is I can use JavaScript for that. So in this case, if I want to edit the record of Alexander Hunold, I double click on this. This is intercepted by a client listener, recognizing the double click, which would then inform the server. And the server responds with a pop-up dialog showing the edit form. And now I can edit the record. When I press submit, then the table gets refreshed with the changed data. So let's have a look at the implementation code for that. This is the implementation code. So the function is handle table double click with an argument. As I said, I prefer EVT. From this EVT, which is the argument or the object that represents the event, I'm going to get access to the source. In my case, this is the table. And then I can use a custom event to queue a server-side event. And I'm talking about custom events in a minute. So I take the event, get the event source, and send a message to the server to tell it that it should bring up a pop-up with the edit form. And then I'm canceling the event because I'm done on the client. There's no need for the double click event to go to the server because there's nothing specific for the server to do there. And everything the server needs to do is what I specify within ADF custom event queue. So let's scroll down and look at the client listener definition, which is a child added to the table. So here I have a method defined, handle table double click without the argument, and the type I'm listening for is double click. And then I do have a method called, or not a method, it's a server listener tag defined as table double click event. So that is the name of the server listener. And as you see, this calls an expression language method on the server side. Yeah. And the client listener calls the JavaScript function, and the JavaScript function calls the server listener to send a method to the server. And we talk about this next. To pass information, additional information to the client, I can use a client attribute. I mentioned before that you might have to bring additional information to the client that is not available by default. One use case for additional information is like if you want to write generic code, and the generic code should not make any assumption about the server listener. You could see that in my example that I showed you before, the server listener reference was hard-coded. So I knew about the name of the server listener in my JavaScript code, which is okay if the JavaScript code sits on the same page as a server listener is in, because then looking it up is pretty easy to do for me. But if I'm writing generic code that ends up in a JavaScript library, then I cannot make this assumption. I cannot have a function that requires the developer to create a specific server listener, because for sure he or she will forget. So in this case, you may want to bring that information about the server listener to the JavaScript function. And you can do this using a client attribute. Client attribute is a tag that you find in the operations category of the ADF Faces component palette. You drag and drop the client attribute onto a component, give it a name and then a value, where the value can be a static string or an expression language referencing some other information. A client attribute also is a way to associate a specific client ID with an event. Now imagine like I want to access a specific component relative to another component, and I have an event object which is executed, say, on a table. Now I could add a client attribute to this table and providing the information about the client ID of the object I want to access. So making my search easier by providing the client ID as a client attribute on the table object, though the client ID wouldn't be the ID of a table. So it would be the ID of another component I need to access just to get my work done on the table event. Now this is what I can use client attribute for. Another option to use is a JavaScript callback. In my initial JavaScript sample, I used a function with one single argument, which I called EVT. Now, to call this, I use a client listener with a method reference that just has the name of the JavaScript function in it. The more generic JavaScript code I want to write and the more reuse I want to promote, the more likely is that I need to pass in additional information straight to the JavaScript file. And I don't want to have the JavaScript file making any assumption about the availability of client attributes or the availability of the existing of some server listeners or whatever. So I want to pass this information in. So I'm defining a contract between the user of a JavaScript library and the JavaScript function and the function itself. In this example, I just defined a function which will expect a title input, and the title would be put on top of a dialog. So in this case, what I do is I use a JavaScript callback in which the JavaScript event handling function is within the return of the function that we call from the client listener method. You see that we call the client listener method as show popup from action and then please confirm. But within this show popup from action JavaScript function, we do have a return function, and then we define the return function, which is actually the event handling functionality in ADF Faces. You see in this JavaScript code that I still do some assumptions about the component ID, so I hard-coded this to popup, and the dialog ID, I hard-coded this to dilg1. Now I can replace this as well with an argument. So instead of defining show popup from action title, I can do show popup from action title, comma, popup ID, comma, dialog ID. And then in the calling method, I will just add this information to the call to the JavaScript function, pass that information in, and now this JavaScript function could go fully into a JavaScript library, as there is no longer any dependency to any context information that I should be aware of when executing the JavaScript. So you can write 100% generic code using the JavaScript callback. For everything else, where you don't need to have this high degree of reusability, you can actually just use the client attribute, as it's a very convenient way of doing so, or if everything is just in one single page, even hardcode things and reference it directly from the JavaScript. But if you strive for reuse in your JavaScript development, if you want to have browsers caching the JavaScript external files instead of just bloating the pages with lines of JavaScript, then this is the approach to go for. In my example with the double click on the table, I already had an example on how to call Java on the server through JavaScript. Now this is the follow-up slides on how you do this and why it's working the way it works and what you need to do to set it up. So invoking Java on the server in fact is the common requirement in Ajax, and this is really what makes Ajax strong. The JavaScript code on the client side conditionally calling out to the server, fetching data, getting information and displaying new content. And again, JavaScript is not an excuse not to learn about ADF Faces properly, because in ADF Faces there's a lot of functionality like partial refresh and partial submit that allow you to have this effect of asynchronous server-side data fetches without reloading the page that you don't need to code JavaScript for. And always keep in mind that if we look for future safety, if you want to migrate your application to some future release, whatever change there will be, it's easier to migrate metadata text than JavaScript lines, which typically fails. So whenever you can stay away from JavaScript, you're asked to do so. However, for the cases where you need to have JavaScript to invoke Java on the server listener is the tag to go for. So the AF server listener is available in the operations category of the ADF Faces component palette. It has two attributes. One is the type and one is the method, as I showed you in the live example. The type defines the name of the listener to access, and the method defines an expression language reference to a managed bean. And the managed bean method has one single argument, which is of type client event. Within the call to queuing the message to the server, you can pass a payload, which in some cases is required just for the server side to do the right thing. And the payload is passed as key value pairs, and you can pass as many as you want and access these from the client side. You can also decide where in the life cycle the client event should be executed. If you set the last argument in the call to queue to immediate, then this will be handled first in the request lifecycle. If you just have this immediate setting defined as false, then it will go through the normal processing lifecycle. And here's an example. I have an input text field that has a client listener assigned to listen for the key up event. And whenever this happens, it calls JavaScript called handle key up, which in turn calls the server listener to send the current values typed into the field, the string that's currently available as a value of the field, to the server just for printing. To do this, the JavaScript function uses a call to ADF custom event, which is a static class, and then queue. So it's queuing the event so that with the life cycle it's sent asynchronously to the server. As a referent, it needs to get the input text component, which it can get from the event, because the client listener is the event. It's a key mouse event that comes up, or a key event, not mouse event. Then it referencing the server listener, and it passes a value as a payload, and the value is passed as a property f_value, which is just the name I made up. So that's up to you how you name your properties that you pass to the server. And the value itself is read from the component handle getSubmittedValue. And then the last argument is false, so that goes through the normal lifecycle processing. And after that, event cancel is called. Where in fact this is a typo on the slides, by the way, because it should be EVT cancel, it shouldn't be event cancel. So EVT cancel would cancel the whole event so that the key up notification is not traveling to the server, because there's no need for that. On the server there is a method handle server event, and the handle server event has a single argument of type client event. From this client event I can get access to the parameters, and in the example I'm accessing the property f_value that I pass with the submitted value of the input text field, and then I can just print the message. So this is how you call to the server. Where I can call Java from JavaScript, for sure there's a way to call JavaScript from Java, and this is what I can do as well within ADF Faces. ADF Faces is based on Trinidad, on my Faces Trinidad components, and they do have a utility class which is called Extended RenderKit Service, and this allows us to stream JavaScript, either JavaScript data or a command, to the client side and have it executed there. To call JavaScript from Java, I created this helper function or helper method which is called write JavaScript to client, which uses the extended renderKit service to pass a string which represents a JavaScript to the client side for execution. So we see the call pretty much easy and straightforward. Extended renderKit service, service.getRenderKit service to get a hold on the renderKit service. We pass in the Faces context and the renderKit service as a class, so we have the object reference. We get a handle out of this, and this handle has a method called addScript, and that's all we need to do. Just pass in the string for the script, and then with the next response the script will be sent to the client and executed there. The example I have below uses this helper method just to bring up a pop-up, just in case a pop-up on the client isn't opened already. So it checks if the pop-up is there, and if the pop-up is not displayed, then it will display the pop-up. Kind of conditional launching of a pop-up. For this example, note that if you're on a release equivalent or later than JDeveloper 11.1.1.3, pop-ups can be launched through a Java API also. Yeah, so we try to eliminate the need for using JavaScript, and one of these elimination processes is to provide a Java API to launch a pop-up from the server side. But in releases before 11.1.1.3, the only way to programmatically launch a pop-up was to use JavaScript within Java to call it on the client side. So let's have a look at the more advanced example of how to use JavaScript. In this example, we use JavaScript to listen for keys, for keyboard shortcuts. Developers coming from a forms background might have enjoyed the FRM web resolution file that allows developers to specify keys that then, if the user pressed this within the context of the application, queried the form or insert a new record, deleted a record. And you can do similar thing with JavaScript in ADF Faces. So first of all, if I press Ctrl K in this sample, then the keyword combination is intercepted by JavaScript. Then a server listener is called to ask the server side what to do with this keyword combination. And then this Ctrl K obviously launches a dialog with an overview of functionality provided as keyboard shortcuts in this application. So let's play with some of them. So first of all, in JDeveloper there is an interesting feature that is, if you have too many tabs open and you want to jump between a specific tab, then you can assign a number to it, so that when you press Alt and number, you can switch to the specific tab. To register this tab, you press Shift Alt and the number. So Shift Alt 3 adds 3 to this tab. Now let me go to another tab, make this the current tab. So now I'm pressing Shift Alt 5. And you see the number 5 being assigned to the tab. Now this is not a native function in ADF Faces. This is something I developed for the sample. So I'm listening for the key combination, send a server listener notification to the server, and in the manage bean I figure out what is the key that is clicked, what is the component I'm on, and then I do the right thing according to the keyword combination. And here I'm using a payload, and the payload actually brings to this client exactly the keyword setting that was pressed, or this keyword combination that was pressed. Now to go back to my home tab, all I need to do is press Alt and 3. Again, this goes to the server and does the right thing. Alt 5 brings me back to this tab. If I want to deregister a tab, I could just Shift Alt and press 5 again. Then my server-side logic recognized that this tab has been registered already with this keyword combination, which means a second registration will unregister that. Another functionality to show is to bring up a list of value if a field has a list of value defined. So we can scroll here in the table, and you know that you have users that prefer to tap through input text fields. They don't necessarily want to use the mouse to click into the field. So I'm moving my mouse out of this field here, and if I want to bring up the list of value, instead of just clicking onto the list of value icon, where in fact this is not the list of value, it's an input text field, so let's move to the list of value, which is here. So instead of clicking on this magnifying glass just to bring up the list of value, I can press Ctrl L, where Ctrl L is a keyboard combination I defined in my sample to bring up the list of value. For this list of value to bring it up, I call the server identifies the keys that were pressed, and then it will issue JavaScript back to the client to launch on the component the list of value that is associated with it. So this is kind of a two-way thing. Not for every key that I'm intercepting on the client side I have to go to the server. It's just an implementation detail, and it's completely up to the developer how to build things. Another thing I could do, and that's also something that Forms users had available in Oracle Forms, is the ability to duplicate a row. So let's go for Nina Kocher. So selecting that bracket. Now if I press F4, then I create a duplicate record for Nina Kocher. So the table gets refreshed, and when it comes back, you see it duplicated the record for Nina Kocher. So let's provide some employee ID for that. Now we go to the original Nina Kocher, and now I can press Ctrl D in my sample to delete the previous record. So this also goes to the server. It will notify the server about the event, about the key combination that is pressed, and we see what's left over is the Nina Kocher that we have newly created. Yeah? And I can map all kind of functionality using JavaScript with this. It's always the same thing. I'm listening for a key combination, I'm then calling a managed bean on the server side, and then I respond to whatever needs to be done. So F11 should do a rollback, which is the way I coded the program, so that we should see the old Nina Kocher coming back. And here we go. So this is a more advanced sample, because that requires some understanding of the JavaScript architecture and how to work with, but it shows you the possibilities you have in here. And that's a functionality that's not yet available in ADF Faces, that we might bring in as a feature, but it's not there, it's not planned. So if you need to do some global key function thing, then JavaScript is what you can use for that. Alright, so far we talked about the building side, how to create things. Now it's time to talk about the disadvantages of JavaScript. One disadvantage, of course, is that it's an untyped language. Another thing is, how do you track JavaScript problems as you might experience them? First of all, JavaScript by default is obfuscated. That means that we're condensing it to a smaller size so that the performance when you load the page is good. To debug JavaScript with Firebug or with some other debugging facility, and you need to uncompress or unobfuscate JavaScript, which you do with a WebXML parameter. It's called org Apache MyFaces Trinidad debug JavaScript. You set this parameter to true. If you set this parameter to true, then obfuscation is switched off. In this case, by default, it's not enabled. That means that JavaScript is obfuscated, and you see a lot of JavaScript variable names that make no sense at all to you. Yeah, for debugging, you want to enable that. Then we can perform client-side logging. Again, it's a setting in the web XML file where I can specify the log level. And what will happen is whatever is getting written on the client is printed to the console. In Firebug, if you switch to the Firebug console, you see a lot of information being printed by the normal way of working within the client. Or if you, as a developer, if you in your function code print a message on the info level, like what I'm showing there, if I call ADF logger log message, and then similar to what I do on the server side, I just choose the logger level and then the message there, this also gets printed to the console. In my global keyboard example, for example, I had an info level logging which showed the key combination as it was registered and intercepted by the JavaScript, so that I could see that the JavaScript understood the keyboard combination. Information like this that you need to be available on the client side when debugging problems, this is what it can do with an ADF Faces. So it has client-side logging, it goes to the console. Right now, the best tool to use for that is Firebug in Firefox. There is a fix that we expect to be in 11.1.1.4 for Internet Explorer, so that you can use the Internet Explorer 8 integrated console as well. Otherwise, Internet Explorer is not quite as good in terms of debugging JavaScript or showing log level information on the console than Firebug is for Firefox. So even if IE is your strategy in your company, for development purposes, maybe Firefox and Firebug is an option to use during development. So that's about logging. As server-side logging, we have client-side logging as well. If you want to enable logging at runtime, and I didn't show that in the demo, but you've seen that there was a select list with log level information. I can do this dynamically. I can enable logging at runtime. So even without configuring it in a web XML file for general logging, I can have a conditional logging defined within my JavaScript, where I just call ADF logger set level, and then I set a specific logging level, which automatically will start the client side to print out log level information. That allows the users to navigate just to the point where the problem occurs, and then you enable logging, and then you see only the printouts for the area where the problem is. To handle the untyped case, ADF Faces provides assertions. Assertions is a framework functionality that allow you to test if a specific argument you're working with in your JavaScript function is of the correct type. Like, is it a number, or is it a string, or is it a duplicate, or is it an object? Things like that. Yeah, everything that you on your JavaScript function need to make an assumption of or about is what you can test with assertions. What happens is, if you have an assertion that fails, then actually it will throw an error. So it will show an alert. There's no way, for instance, to change the error behavior to just logging the error, because assertions is not something you should use at runtime. You use this at development time only. Using it at runtime is a performance gotcha that you don't want to risk your application for, right? So just use assertions at development time. Never use it as runtime or in production. So a failed assertion immediately brings up a dialog with the error message. To enable assertions, you use a web XML parameter. So it's called Oracle ADF View Rich Assert Enabled. You set this to true. This enables assertion for the session. And then in your JavaScript function, I have a function called do something, where the argument that I expect to be passed into my library is a numeric argument. So I check ADF assert dot assert numeric if this argument is numeric. If not, I just print out a message that will be shown with the alert. And then I do have my function code there. This assertion really makes sense in the context where you build reusable JavaScript libraries, where you're not the same person building the JavaScript function and the page functionality. You know? So what happens when assertion fails is, here is an alert coming up, and it says assertion failed, numeric failure for argument numarg value is passed in as 1. So I can, based on the use of this assertion, I can give the right message to the developer for him to understand what exactly was passing wrong to that function. But again, only use that for development purpose, never at runtime, because first of all, it doesn't make sense for the users to see this dialog, and second, this really only is of good help if you're a developer being able to fix the problem. Finally, before we finish this presentation, a word of caution. It's always that JavaScript bears some risks, and we need to talk about this as well. So the best practice to work with ADF Faces and JavaScript is listed on this slide. First of all, understand the ADF Faces client architecture before using JavaScript. Don't guess around. Don't try to hack anything in ADF Faces. Don't change the framework. Don't use the DOM tree. Yeah? Understand the ADF Faces architecture and the client architecture. Take your time. The whole JavaScript development is documented in the Web Developer Guide in Chapter 5. So everything you find there describes the client architecture and how to use the JavaScript programming within that. Also, probably in December 2010, there will be a white paper released about JavaScript use in ADF Faces. We will also cover how to set up the samples that I showed throughout this presentation. Don't use any protected or private functions and variables shown in the DOM tree. If you use a DOM introspection tool, don't do this. Don't use any function that is private, protected, or an internal package. If you see JavaScript failing or not working, ensure the component that you're trying to access is available, either setting the client component to true or adding a client listener. If you see a never-ending spinning O, that is a clear indication that the object you're trying to access is not accessible. Don't hardcode client component IDs. It may be safe to code component IDs, but client component IDs, which are the generated strings out of naming containers and instances of an ID, might change between runs of the same page. So always try to get the client component ID dynamically through expression language, in that you have a managed bean reference to the component and call get client ID on that reference. Cancel all events that you don't need to propagate to the server, because that is an unnecessary round trip. You don't want to do this. So on the object, in my case always been EVT, call cancel if you don't need this to be going to the server. Use client to server calls sensibly to avoid unnecessary network traffic, which also goes in line with a cancelled event. Don't use JavaScript for any sort of application security implementation. Application security coded in JavaScript is not secure. There's no security on the browser. The browser was never designed to be a secure environment and a safe environment for applications. Don't use your knowledge about framework internal APIs and implementations in your JavaScript code. Always stick with the public API. I understand that sometimes it's easy to reach out to an internal peer class just to override functionality there, just to make the component behave as you want it to behave. But keep in mind the risk. With every upgrade of the tools, you get a set of JavaScript APIs, and there's no guarantee that what you changed in your custom code is then not changed in a future release, which means that your code breaks, and if you're unlucky, then whoever developed that code actually may not longer with you, and you have to go into that, understand the code, rewrite the code. So always stick with the public API. Never accept any use of internal APIs. Handle exceptions graceful. So make sure that you're never suppressing any error within the try-catch block. Even within JavaScript, you can have a try-catch block where you access an exception, handle the exception, or suppress them. Always handle it gracefully. Handle it as close as possible to where it occurs. Using assertions during development is one way to make sure that exceptions don't occur, because you have the guarantee that throughout your testing of your application, you check if the arguments you pass into the function are correct. Very important, don't fight the framework. Never override a component functionality by calling its prototype handler. The JavaScript client architecture is built and tested as is. If there is missing functionality that you cannot build with the public APIs, go file a service request with customer support. Stay away from hacking into our framework. Don't try to leverage the internal communication channel that our client architecture has to the server side just with your custom JavaScript. This will fail. This is no guarantee that that will work. So never fight the framework, always go with the framework. Always think twice before you use JavaScript. JavaScript should be used by exception and never as a rule. Try to find the solution in Java Server Faces first. And always keep in mind, JavaScript is not a silver bullet. It's not meant to save developers from learning Java Server Faces or ADF Faces. It's just an addition, a convenient way to provide client-side functionality that otherwise you won't get. This concludes this ADF Insider session about using JavaScript in Oracle ADF Faces. There are some additional information I want to give. To get more information about everything around ADF Faces, go to the technology subpage or path on oracle.com. There is a JDEF page with it where we provide software downloads, tutorials, discussion forum references, samples like the JavaScript ones, and we also point you to all kind of information that exists around ADF and Oracle JDeveloper. 2 pages I want to point you out is, first of all, the homepage of ADF Insider. If you found this recording through Google searches, then there is a web page associated to this where you find all the ADF Insider recordings, and there will be more as we go with different topics, fairly advanced topics, so you can learn from that. And then there is ADF Code Corner. ADF Code Corner is a web page that provides samples like the splash screen for the long-running query that you can download. It comes with an associated document for you to learn how to build that and what it exactly does and how it does it, so that you can build your own custom development easily based on the solution that you find on the web page. There's also a new website not listed as a link, which is a blog called the ADF Code Corner OTN Harvest, which summarizes interesting topic from the Oracle discussion forum. Books. We're happy to announce that we have 3 books about JDeveloper and ADF out. There's the Oracle Fusion Development Starter Guide, which just is an introduction to the whole ADF development for people who have no background in Java development. There's a JDeveloper 11G handbook that is end-to-end tutorial stepping you through building an application with Oracle JDeveloper and ADF, which is good for people who are kind of familiar with Java and want to taste ADF and try it out. And then there's a more advanced Oracle Fusion Developer Guidebook, which in chapter 19 has a lot of the topics covered that I covered in this session. This concludes this ADF Insider session. Thank you for listening, for watching, and see you back on ADF Insider.